So we know that m equals v over u. And we want to find the focal length. Now to find the focal length, we would use the lens law. 1 over f equals 1 over u plus 1 over v. We know the image distance, but we don't know the object distance. Therefore, we use our magnification to find that. So u equals v over m. So it's 85 millimetres. And as long as we're consistent in our distances, we can use either millimetres, centimetres or metres, but we must be consistent over the magnification, which is 1.7. This gives us an object distance of 50 millimetres. And that's the first mark in this 3-mark question. We then substitute that into the lens law. So 1 over f equals 1 over 50 plus 1 over minus 85. Now we must have the minus as v is virtual. And when we calculate that and find the reciprocal to find the focal length, we find that the focal length is 0.121 metres. We'll find it in millimetres and then convert it to metres. You get a mark for the correct substitution, including that negative sign for the virtual, and then a mark for the answer. So 3 marks in that question. So to summarise the complete question then, in part 1, part A, we were asked to distinguish between a real image and a virtual image, and then state the type of lens which under suitable conditions can form real or a virtual image, and that's a converging lens. Then part B focuses specifically on a diverging lens this time, and it asks you to draw a ray diagram to show you how an image is formed using a diverging lens. And we must remember the virtual aspect of that, and it's where the real ray intersects with the virtual ray. And remember, the eye position is where the rays of light will enter the eye. For a diverging lens, it's always on the other side of the ray from the object, but also the direction of your arrow must point towards the eye, so it must be on the right hand side. And the final part of that question asked us to calculate the focal length of the magnifying lens using the magnification and the image distance. So first off, we found the object distance, then we substituted into the lens law, remembering that we have a virtual image, therefore it's minus 85, gives us a focal length of 0.121.